Hi, I'm John Everett with Zurn Industries. Today we're going to do something a little bit different. I'm going to show you how to commission a ZW209 automatic control valve of the pressure reducing variety. What we're going to do is go out into our engineering lab. We've got a valve mounted in line out there, and we'll go ahead and show you how to set these valves up in the field. What we're going to do is go ahead and pressurize the valve. We'll go through all of the bleeding procedures. Then we'll set the valve up for flow so that we can adjust the outgoing pressure. I think you'll enjoy seeing how this is actually done. We provide spec sheets and instruction sheets with the product, but it's always good to see somebody actually doing it in the field. So that's what we'll do next. We'll take you on out into the engineering lab and we'll show you how these valves are set up in an actual field installation. In this sequence, we've got our ZW209 set up in our engineering lab. We've gone ahead and tightened up all of our coupling bolts. And I apologize, this particular valve, it's a ZW209G, it's set up with groove couplings, but we do have all the couplings tightened up. We've got it mounted in line. We've done some pre-assembly here in the sense that we've set our speed controls. I wanted the valve to be equipped with both opening and closing speed controls. In the case of the opening speed control, I'm starting with it open 3 full turns. The closing speed control, I've got it open all the way. Now we're going to go ahead and loosen up the plug at the top of the bonnet here, and I want to make sure I get all of the air out of the ZW209. It's imperative that these valves be bled. If they've got air entrained within the diaphragm chamber or within any of the tubing, it makes the valve very spongy. It doesn't quite know how to react. So we're going to go ahead and open all these fittings up until we get the air bled out, we get good clean water flowing. Here we're just going ahead and tightening everything back up. Again, just making sure we get all of our air bled out. And the last thing I'm going to do here is tighten up the plug at the center of the bonnet because we've got all the air out of the valve. Now once again, I've got an inlet shutoff valve cracked and we're just pressurizing the valve and filling it for these bleeding procedures. Downstream we have no water flowing at this time. Now, the next thing that we're going to do in this sequence, with the ZW209, it's imperative that we set the valve's pressure while it's under flow. If you don't, you'll find that you'll get chattering, shaking, etc. The valve doesn't know whether it should be open or closed, so it's imperative that whenever we set a pilot-operated pressure reducing valve, we want to do so while it's under flow. Also note that in my pilotry, I have all 3 ball valves open. I've got the inlet ball valve, the outlet ball valve, and finally the ball valve up to the cover of the main valve itself are all in the open position. They have to be open for the valve to function correctly. Now, where my hand is at right now, that's the outlet gauge. That's going to tell us our outlet pressure. We currently had about 70 psi coming into the valve, and I'm going to try to set it at approximately 50 psi. And again, what that entails is inducing a flow through the valve. This particular valve is 4-inch in size, so its minimum flow characteristics are above 50 gallons a minute. That 50 GPM threshold is where the valve wants to operate correctly. So we opened up a little bit of flow downstream. I gave the pilot just a little bit of a turn to initiate a flow through the assembly. And once again, just to reiterate, we've got our closing speed control in the full open position, and I started with the opening speed control, 3 full turns open from fully seated. Now, with a pressure reducing valve, we want them to open, not too quickly because we can send a surge downstream. Conversely, when the flow rate downstream ceases, we want them to close fairly rapidly. So again, we don't want to send a surge downstream, but we don't want them to close so rapidly that they develop a water hammer. Now what I'm doing is I'm slowly turning the pilot adjustment bolt inward so that I can increase the downstream pressure. And once again, we have a flow rate going through this valve that's greater than 50 gallons a minute. That is the minimum continuous flow rate for a 4-inch valve. When we're adjusting a pilot-operated PRV, we want to do it fairly slow. As you can see there, I'm giving the adjustment bolt a little bit of a turn. I see my gauge catching up, give it another little turn. Ultimately, I want to keep creeping up on my desired flowing pressure. Now I raised the pressure, the flowing pressure, up to approximately 50 psi. I'm backing it down just a little bit. I stepped a little bit over it. It is not uncommon for a pilot-operated PRV like this to have a lockup pressure approximately 5 psi higher than the flowing pressure. That's very common. You know, it takes a little bit more pressure to make the rubber bite into the seat and to finally shut the valve off. But that's very, very close, and it is to be expected with a pilot-operated PRV. Now, once again, we had 70 coming into the valve. We wanted to establish a 50 psi flowing pressure on the downstream side. And to reiterate again, do it very slowly. Give the adjustment bolt a little turn, wait for the valve to catch up. Once we get to that desired pressure, we go ahead and lock the nut down on the pilot, and we might fine-tune our opening and closing speed controls. I had the valve opened and closed on the downstream side just to make sure that the whole pilot-operated PRV was reacting in the fashion that I wanted. It turned out to be so, and we basically lock our speed controls down at that point. Everything seemed to be good. The valve was not surging open too rapidly, nor was it going closed too slow to develop a surge downstream or too fast to develop a water hammer upstream. So again, with your opening and closing speed controls, once you get the pressure set, you'll want to fine-tune those controls, open and close your downstream water flow, and just make sure that the valve's reacting in a fashion that doesn't develop surges or doesn't develop water hammer. Once we're comfortable with that, we're to the point where we quite frankly have the valve set. We want to go ahead and cycle the downstream a number of times just to make sure that the flowing pressure remains constant and also that we don't go static or anything of that nature. And that is the full setting of a ZW209.
Thank you for watching. For more information, please subscribe to our One Zurn YouTube channel. Call our customer care center at 1-855-1-ZURN and visit us at zurn.com.